Connected Components Workbench, Micro800 Controller Programming. This video will cover the first timer exercise in the manual on approximate page 138. This will be a relatively short lab project. In the manual, it's approximately 2 or 3 pages, and it does nothing more than give you your first experience with a timer instruction using a timer data type. In the previous video, we covered the majority of the timer data types and the control elements of those data types. Now we're actually going to use and demonstrate an on-delay timer before we return to our other projects and actually apply a timer instruction in a practical application. Not knowing what you have in front of you as far as hardware goes, I'm going to configure a project just to do the first timer. In the manual, it really doesn't tell you one way or the other whether to use the previous project, delete all the tags, delete all the logic, delete all the programs, or just to start anew. So I'm going to create one from scratch, so that gives you a quick little review. Most of what you see here is not going to appear on your Connected Components Workbench software interface. Notice that I'm using the developer edition. I am using version 11. That's one where you can check, see version 11. And I have the feature pack installed as well. Version 12 will be out shortly, and if version 12 comes out before we finish this series of videos, we'll download, upgrade to 12, make a point of explaining, and then we'll move on. So we're version 11, developer edition, with the feature pack. New, and I will just call this first TON01. I think I'll put a space in there just so it's a little bit easier to read the name of the project. Create. You've seen this before. We're going to pick a controller. Notice that currently, with this revision level of Connected Components Workbench, version 11, it supports 5, we'll call them individual platforms of the Micro800 family. The Micro810 is a controller unto itself. It in no way resembles the others other than the plastic's the same color. Other than that, it uses the same software, it uses the same instructions, but the physical hardware format is completely different in that you don't have a lot of communications capabilities and you cannot expand the I/O. In case you've forgotten, a Micro810, LC10, the 10 designates the level of the platform. This number, 12, indicates how many I/O points you have, and then the 3 characters after designate the electrical interface. Now we're not going to use an 810. Here I can expand the 820s out. The 820 is actually a good choice to learn with because you can add the remote LCD, which gives you a conventional USB port. The LC20 on its own has Ethernet, but does not have a conventional USB port, but it does have a RS-232 interface in the way of terminals, but you have to run conductors from some other device to those terminals to actually use that RS-232 port for programming and monitoring. With the remote LCD, you run 3 wires from the remote LCD to the controller, and then on the front of the remote LCD there's a conventional USB port. Micro830 comes in quite a few flavors, 10, 16, 24, and 48 embedded I/O points. And you see a variety of electrical interfaces for I/O judging by these 3 alpha characters. The 830, I don't use that myself because it does not have Ethernet or an easy way to integrate Ethernet. So the LC20 is probably the most bang for the buck. I have all of these. I have one each, 810, 820, 815, 870. I don't have an 830. I'm going to use an 850. Most likely because that's what I've got hooked up right now on my work surface, and rather than switching it around to one of these other 3 that I have, I'll just leave it the 850. I always buy the QBB because that has the best electronic interface for things like high-speed counters and PTO outputs for motion control. So I'm going to pick that one. And when I select that one, it pops up a description in this window. Now I've not selected it yet. I have to click on this button to select it. You see right there in the middle it says special features, 6 high-speed counter, 3 PTO, and 5 plug-in slots, maximum for expansion I/O. That means that I can add 4 modules off to the right, plus I have these 5 plug-in, plus it has Ethernet, it has an 8-pin round DIN RS-232, and it has USB. Now this is the 48 QBB. If I were to select the 24 QBB, notice that the high-speed counters went down to 4 and the PTOs went down to 2. I wanted to spend some time in other videos highlighting this graphical user interface. I can go back up here and select any of these, and over here I can see what I have to operate with. The QBB is the 810 that I use. So I can scroll down and see the details of each of these. I have an LC20, 20 QBB, that's 20 embedded I/O. And if I scroll up here, I can look to see what it has in the way of special capabilities. I don't see any other than the optional 3.5-inch display, which I am using, and that gives me the conventional USB port. Then there's the 830. We'll pick this one right here, the 48 QBB. This is LC30. And notice it does have 6 high-speed counters and 3 PTOs, which is good. The problem is for communications, it has a USB port, non-isolated RS-232 45 serial port. To that, you could add another device that gives you a conventional USB. So the LC30 is not without its capabilities, but I see no easy way to integrate Ethernet. To integrate Ethernet, it would have to be done through the serial port. You'd have to have an adapter to go from Ethernet to the serial port, and I'm not sure how much the LC30 supports Ethernet IP through its RS-232 port, if at all. The 850 is what we're using, and I'll just quick bump the 870. Now the 870 only comes in 2 versions. I have the 24 QBB. However, if you want to do any motion control, you can see it has 4 high-speed counters and 2 pulse train output capability. But it does have Ethernet, and it has the most processing capability of the 5 groups in the Micro800 family. So I'm going to go back and pick the 48 QBB because that's what I've got connected. And I always pick the highest version available. Now, if my controller is not at that level, I will find out soon enough when I try to download and it comes back and said, you're downloading version 11 project, the controller's at version 8. Do you want to flash it? And then I would at that point. Actually believe that we did that in one of the earlier videos. So I'm going to select this. Now notice it doesn't like that I've jumped around here some. See, it still shows the 820. So I guess I'm going to have to trash that and pick the LC50, then select. At this point, I'm not stuck. I can add more things to my project. Now I don't know if I can do it from right here. For instance, I do a lot with these PowerFlex 525. So I guess I could select that at this point and add it to my project right now. But we're not doing anything with variable frequency drives yet. So I'm going to cancel that, make sure that this is selected, and then add it to the project. Now there's a couple more things that we have to do before we get too far along. And as soon as this is done configuring itself, we'll do those. Now it says it's ready, and you see this is completely empty. Now there is one thing that's important. We do have an RS-232 port right here. That's that round DIN connector, and it has things like baud rate and parity, stop bits. It has a configuration. I have honestly not used the serial port, the round DIN connector like a PMO2 cable on any of these controllers. I either use the USB, which is plug and play, or the Ethernet. I want to use the Ethernet, and you have to set up that port. If I click on Ethernet, and you have to do this offline, you can't do this online. Now, obtain address automatically using data handling control protocol. You don't want to do that, DHCP, because the way DHCP works, you don't pick your IP address, and your controller has to be connected, your processor has to be connected via Ethernet to a network. On that network, there has to be a server that doles out, leases IP addresses, and it's typically done on a temporary basis, meaning that it will give you that IP address for 48 hours or some length of time set by the administrator of the network. And let's say that you disconnect and you come back a week later and connect up, the chances of you getting that same IP address again are pretty slim. It's going to lease you whatever's available. With controllers, processors, in automation, I always pick a fixed IP address. And I like 100, 100, 100, and I'll just use 181. There are IT folks that get all wrapped around the axle when they see this, because they say, hey, you can't use 100, 100, 100. That doesn't belong to you. Well, this is my network. This is in my office. It's not connected out to the internet. It's not on a server anywhere. It really doesn't matter. Now, there are some limitations what you can do here. You typically see 192, 168, and this is either 1 or 2, and then whatever node address that you want. The subnet mask is what defines the difference between the network address and the Ethernet address. The address of this network, if I left this subnet mask at 255.0.0.0, the address of my network, my whole network, is 100. Then these 3 octets, 8 bits, octets, 8 bits is 0 to 255. These 3 are the actual address of the device. If I change this to 255, now my network address is 100, 100, and these 2 octets are the address of the devices on my network. Every time I change one of these Subnet Mask octets from 0 to a higher number, I'm reducing the number of nodes that could possibly be on this network. So my network address that I typically use is 100, 100, 100. That's the address of the network. Then the 4th octet, in this case I have 181. That could be 0 through 255. Typically you don't use 0 and you don't use 255. That reduces you down to 254 possible IP addresses on your network. Now I know I'm splitting some hairs here, and I could reduce this network even more. I could change this. Now I can't change it to 255 because then I have no nodes on my network. So there are some limitations, and you don't need a gateway address. I typically always use 100, 100, 100 as my network address with a subnet mask of 255, 255, 255, 0. 0 means that I can use all 256 values here for something. I always leave the rest of the stuff checked. So now I have configured an IP address that will get downloaded to this controller. However, I cannot download to the controller through the Ethernet address unless I know what the Ethernet address is already on this controller. So I'm going to do a little experimenting here. We kind of went aside from the manual, but I'm going to continue with this. Let's click on the serial port. Now this is a Control and Information Protocol, or Controller Industrial Protocol. The name's been changed a couple times. I can't keep track, so we all call it SIP, Serial or SIP Communications. The highest baud rate for this is 38.4. So we're not going to change anything there. We're not going to change anything I just looked at it to see what it was. So I could plug in to this 8-pin round DIN shell right here, up here on the controller, plug that into a serial port on my computer, and I could go into the controller, upload, download, monitor everything through that port. Or I could do it through the USB. Once I have Ethernet configured, then I can do it through the Ethernet port. Well, the USB is more plug and play than this serial. So we're going to leave everything just as it is. I'm going to click on USB port just to see what's there. Well, there's nothing there. It's just enabled. So you could disable it if you want to. So there's nothing to configure for the USB port. I'm going to set up a connection path. I'm going to do something that is blind-ended because I don't know how it's going to react. I'm going to go to the connection path. I could do it this way and look to see what's there. Or I can just say connect. And I think that's the best route because that other window, that little box I opened up, showed some possibilities of which some are there and some aren't. Ethernet IP. Obviously, I have an Ethernet IP driver configured. I'm going to cancel out of this since I'm just kind of exploring with you. I'm doing this as we go, and I'm going to open up RS Links. I'll bring it up on the screen. It's already open. Give it a second here, and we're going to go to Who Active. So Links is not completely awoken here. Now you notice that these look the same as what we saw when we clicked on Connect, or something like this came up and it wanted us to pick one of these. I go to this, expand the AB Ethernet IP. These three Ethernet addresses that come up with red X's, RSWho remembers who it saw before. The red X's say that these IP addresses we've seen in the past. You see it's a 1769 L32E. That's a compact Logix that's programmed with RS Logix 5000. I do mostly RS Logix 5000 training and work and engineering. Then second to that would probably be RS Logix 500. There's nothing there to connect to. It does not see that controller. And that controller has an Ethernet cable plugged into its port and plugged into my network, and it doesn't see it. That would be because it's not on my Ethernet network, which is 100, 100, 100. So that means that that controller, whatever it's set at, which is probably set up for boot P or DHCP, and by the way, boot P is Alan Bradley's version of DHCP. However, boot P is a little better, but you still have to have a server that assigns IPs. The nice thing about boot P is that when you power up a processor on the network, it sends out its MAC ID. And the MAC ID gets to the server compares that MAC ID to a list, and if it finds it on the list, it will send the corresponding IP address down to that processor. But if you haven't set that up on boot P, you can't do that. We're not going to use boot P or DHCP. We're going to use fixed IP. But I wanted to show you this. Now this, if I click on this, what it's saying is we saw an 870 plugged in here before. Now we don't, but we see the 850. I'm going to go back to here, and I do have to use that USB path though, because remember I couldn't get in by Ethernet. Go back to that same spot, USB, and see, we see the exact same thing that we saw in RSWho. Now I'm a little, okay, there's the red X. I was a little surprised when the red X didn't pop up right away. So see down here where it says OK, grayed out. Click on that. Now it's not grayed out, okay? All that I did was told Connected Components Workbench that I want to connect to something. I didn't tell it I wanted to download. That would be up here. See, download, upload, download, build. I just said connect. Okay, it connected, and it looked at what was in that controller that I want to connect to. It looked at what's up on the screen here in this project that I titled First TON01, and it's saying they don't match. See right there, current project content does not match the content in the connected controller. So you want to download what you have in front of you or upload what's in it. Now I don't want to upload what's in it because I'm treating it as a raw controller with nothing in it. I just took it out of the box, even though that's not true. That's how I'm treating it. I went through and set up the Ethernet here. That's what I want to go down there. So download current project to the controller. It evidently found the controller in the run mode. Now, I've been using this controller. It's not a fresh controller right out of the box. So now it came back after it looked at what I wanted to do and says download overwrites the project in the controller with the current project content. This pop-up is a little different than the previous one. The previous one was download to the controller or upload from the controller. Okay, that gave you your first decision to make. Do I want what I have in front of me down to the controller, or do I want to upload what's in the controller first, save it with a different name, then download what's in front of me? That way I have not lost what's in the controller in case I want to go back to that. We said download. Now it comes back and says that controller will be automatically switched to the program mode. That's because it's in the run mode. It's like another verification. There's two ways you can go from here. If I say download, that's going to download just the project, but not any values in the database. Well, guess what? We don't have any project values yet. But I'm going to do that anyway because that's typically what you would do when you download, because if you go offline and you change some project values and then you download without those project values, now what's in your controller is not the same thing that you have offline. So download with project values. Download is complete. Change the controller to the remote run mode to execute the controller project. Now I'm going to say yes. Now we're not exactly doing what we had in the manual yet. Okay? All that I wanted to do was to get the configuration of the Ethernet port down into the controller so I could use a different path to connect. So I'm experimenting in front of you. Okay, so it says download succeeded. I'm going to say disconnect. Okay, so we just downloaded. I'm going to disconnect. Now I'm going to edit. I can clear the connection path, or I can set up the connection path. Now we already have a connection path here. Temi, that's me, that's my computer, and USB. But I don't want to use that. I want to use, I believe, this one right here. Okay, so this is my laptop. There is no 810 connected. I don't have the remote LCD, which connects up to the LC20. And I do have the USB though. See right here, over here, PC USB 15, that's this one. That's my controller. It says to select path. Well, this is my computer right here. So then you have to ask yourself the question, am I picking this or this? If I was setting up the Ethernet IP driver, it would be my laptop or my computer, but I'm going to this unit right there. So I'm going to double click to set that path and then close. Now I'm going to connect, and you see I am connected. The reason I know I'm connected is because it shows run here. See, it's green, remote run mode. Now the LC50 has a little toggle switch on it, and I'm going to flip it to the run position. You watching up here? I flip the toggle switch to the run position. I go back to the middle. Now it's remote run. I go back to the other side, and I'm in program. Now, in the other Allen Bradley software, program is normally cyan in color, kind of like bluish. And then anything run is green. You want to leave that in the remote position because that's what allows you to online monitor, edit, etc. Now, not all the controllers allow you to online edit. I'm not even sure all the versions of the software allow that. You see, I have up here run mode change. I'm not really sure whether you have to have the developer edition to have this online editing capability or not. And I guess I should go read online and see, but you can do that. You can go look online to see if you have to buy the developer edition to get the run mode change online programming. We're happy now. The processor's happy. Now I'm going to go back offline. I'm going to save, hit the save project. It's interesting, that's still a little floppy disk symbol 2.5-inch floppy disk with a little hard plastic case, and it's got a little metal guard that slides to expose the ferromagnetic material on the little floppy disk. It's interesting that that has not changed over all these years. Okay, now I'm going to disconnect. I can do that by clicking here to disconnect, or if I click here, see, this shows I'm connected, and I can click to disconnect. So I'm going to disconnect, and the next thing I'm going to do is create a program. We're going to call the program Timers. Now you've already done this. This isn't your first lab project, and if you don't have the manual in front of you, some of this won't necessarily make any sense. You can still learn something by watching it, but it's not the same thing as having the manual in front of you while we're discussing this topic. Programs, right click, add. So far we've done nothing but ladder diagrams, and we will stick with that through this entire manual, and then in subsequent manuals we'll do structured text and function block diagram. Now if you're not familiar with these three languages, these are 3 of the 4 that Rockwell uses in their controllers. In the older platforms it's strictly ladder diagram. In the RS Logix 5000 Logix engine processors, you have 4 languages. Of course, ladder logic diagrams, structured text, function block diagrams, and sequential function charts. This does not have SFC. Can they add it? Maybe they will. I think it's a marketing thing. So let's pick that and add this program. Right click, rename, Timers. Let's open that program. We can do that. You see up here we have start page, and then we have the controller tab, and this is where you go to look at all the setup. You can also do upload download from here. Typically we don't. Start page, we really don't need to see that for anything. This tab you probably should keep open. You could close this tab if you wanted to. I double click on Timers, and that opens up a 3rd tab up here, and that is the program. Now, there's nothing in there except an empty rung. See this black line right here, dark gray? That is an empty rung. In all the newer platforms for Rockwell Automation, when you open up a program file or routine, if it's empty, it opens up with a blank rung. So we don't have to add a rung here. See, we could drag one down, but there's no reason to do that because we have a rung right here. And I had you put in a TON. Why they put the timers all the way down here, and maybe you can move these around. I haven't tried that. Oh, yep, you can do that. So bit, rung branch, let's go down here to, I wondered about that. So I'm going to grab timer counter and I'm going to drag it all the way down to there. Well, one more. And the reason I did that is because favorites, you can set up what you want up here for favorites. Bit are all of the bit instructions. We've covered a few of these, and we'll cover almost all of these at some point in the manual. Rung branch gives you branch, branch around, and instruction block, of which you would then define. So there's really not much here that you're going to use, and the branch around is usually found in the favorites. See, all 3 of these are in the rung branch. So I'm going to drag that out of my face to the end and then come back. So now I have favorites, bit, timer counter, and I would say that compare and move copy are the 2 most popular after these. So that's my lineup right there. So I typically just go to favorites because most of what I want to do is right there. Now in this case it's not. But if I go to timer counter, I'm not going to get a bit. It is interesting though that they put the rung and the branch around in with the timers. Let's see if they do that. Oh, they do that with everybody. Oh, that's nice. Okay, we want favorites. I'm going to grab from the timer counter, I'm going to grab a TON and drop it in here. Whenever you see the plus sign, you can let go of it when you see it highlighted. Now, it automatically came up and named this instance of a TON, TON_1. And I had you download this as is. So I'm going to click on download, pause, and then come back when it's downloaded. What we did in this first couple steps in the project was to add a TON instruction into a rung, leave the rung unconditional, meaning that there are no permissives or conditions between the head of the rung and this instruction that determine whether or not you have a true rung in or a false rung in. So this little dark red spot here that you may or may not be able to see is a true rung in from the header. So the header is always if, and then this is true in, and then if there's something in here that can change it to false, then this would be blue, and you'd have false in instead of true in. But this is unconditional true in, and Q is not controlling anything. We have no instructions out here, and we have no preset. Because this is true, and the ET is equal to the PT, 0 is equal to 0, then Q is on. If we actually had a preset value in here, Q would not have been read until the ET had incremented, accumulated counts of units of time until it reached a value equal or greater to PT. That's all we did, is showed you what you can get away with. Now this is useless, but it gives you an understanding of what CCW will accept. Even though this is useless, it will still accept it. It doesn't find anything wrong with this. It has no idea what you're doing. Maybe you want this TON to be done continually. So it's unconditionally true, and the ET, as soon as it hits 0, which is when it goes true, then it turns Q on. TON_1.Q is a legitimate bit. Let's see if it put it in the local variables. Double click on the local variables. There it is. And there's the bit right there. See? Timer on delay _1.Q is on. See? It's enabled and it's on. I'm going to close the variables. Now, I told you to disconnect and go offline to edit your logic. Now, if I go back to the Micro800, I see a disconnect there, but I don't have to do that. I can leave it right there, and I can go up here and click on Connected. So this little button up here is a dual purpose, and is an indicator and an operation. So I'm going to click on that to go offline to edit. Now you notice it goes offline a lot faster than it downloads and goes online. Ethernet helps that some. If we were still using USB, that is slower. What we added next when we edited this rung of logic, because it was unconditionally true and Q wasn't being used for anything, we wanted to change that. So you go to favorites, we'll drop down a true if on. Now notice it says direct contact. That's what it was originally called in CCW. And then the original Allen Bradley speak was examine if closed. Examine this bit in memory, and if it acts like a closed relay contact, then it's true. How that's a mouthful. It's just easier to say this instruction is a true if on. True if the bit that it addresses in memory is on. Now I could type in the memory location. In this case we're using I/O, and I used the first input. So I go right down. Now remember, this is a 48 QBB, which means I have 48 embedded I/O. So I have to go all the way down to the 20th output, 0 through 19, that's 20. Then go to the first input, select that. Okay, this instruction reads that memory location, and if it's on, then it's true. That's simple. True if on. We also want an OTE, direct coil or output energize, and we throw it there. We don't have to throw it right on the plus sign, but somewhere close. And we're going to go to I/O again, and we'll scroll back up and see how it leaves the scrolling list in the position you left it. I suppose that's good if you're going back and forth a lot. So I'll pick that one and accept it. Okay, now this timer is not going to see a true in unless that input is on. And when the input goes on, because we have no PT, we have 0 really for the preset value, this true in will turn on that bit immediately and turn on that output. But we don't have to do that. I'm going to have you put in a value. Now I realize in the lab at this point I had you download it to see that the only thing that changed is that now you can turn this on and off. And then as soon as I turned this on, that went on immediately because there's no preset. So the ET equals the preset instantly. I'm not going to do that because I think that's fairly straightforward. What I am going to do though is I'm going to create a tag, so to speak, and it really is a constant. It's a variable, but of a timer data type, an element, and it's T # 1500 ms for milliseconds. We've got something. And that's really all that we need. I'm going to save this and download it, pause, and then come back when it's downloaded. Online with our rung of logic, we don't need to keep this output window open here. The only time that's of value is if something doesn't work right. You can look down there to see messages. Here is our single instance of a TON instruction using the tag named TO1_1. We have a precondition or a permissive here of digital input 0, and when Q goes high or true, when Q is true, then it will execute this instruction, which turns on that bit in memory, which is a digital output. So we have 1500 millisecond preset. That's a tag of a time type, 1500 milliseconds. If I made it 1500S, then that would have been 1500 seconds. And we'd have been waiting a long time to see this time out. What I would expect to see is when I turn on digital input 0, 1.5 seconds later, that output should come on. Now I want you to notice the little red spot right here next to the rung header. In text language, this would be the if. If this bit is equal to 1, then enable this timer data type. Else, disable it. If Q is high or 1, then true rung out and execute the true execution of this OTE, which turns on that bit. Else, turn it off. I'm going to execute input 0, and what you should see is you should see that trueifon go red, and then you should see the timer data type accumulating ET, and when the T#0S red there equals T#1500 ms, you'll see Q out go true, and you'll see the output come on. See, accumulating, red, it's on. When I look at my digital field device simulator, as soon as I turn input 0 off, it clears everything. It's reset. If I look at my digital field device simulator, I flip the switch, the light's off, now it's on. That's it. That's all there is to it. On delay timer. It delays the transition of the in side to the Q side by whatever the length of PT is. That's simple. I had you also open the local variables and expand this instance of a timer data type and look at these values. We already looked at this once before, back when it was 0. So now you see we have they call it a program time, I call it a preset, and you have an elapsed time, which I call accumulate, because this timer data type counts units of time of 1/1000th of a second. Now, if I had put in 1s for 1 second, it's not going to count units of 1 second. It's still going to count thousandths of a second. The nice thing about the timer data types in both CCW and in RSLogix 5000 is that they are 1/1000th of a second. They count 1/1000th of a second. And the reason you can get away with that is because in the older platforms, if they gave you just 1/1000th of a second and you only had a signed integer, which means it could only count up to 32,700 and something, you had to be able to pick 1 second so you could count up to 32,700 and so seconds in order to get a real long time delay if that's what you needed. But with 32-bit dense double integers, for every single bit that you add to those 16 bits, you double the count that you can get. So using 1/1000th of a second, you can still get really large values of time even though you're counting thousandths of a second. At this point, I had you disconnect and save. So disconnect and save.